Hello students, and welcome you all again to this video lecture series on chapter Introduction to Powder Metallurgy. Up till now we have seen what is the significance of powder metallurgy, what are the steps in powder metallurgy process, what are the applications of that, what are the methods of powder manufacturing, then what is a mixing and blending, how we can do it, compaction methods, what are the sintering processes and their types, then what are the advantages and limitations of powder metallurgy process. So after that we have to see the typical powder metallurgy applications and their flow charts. So with the flow chart we have to see the typical applications. Three typical applications we have to see, that is a self-lubricated bearing, second cemented carbide cutting tool, and third one is a friction material. So these three we will see in detail with their flow charts in coming videos. So firstly we will start with the self-lubricated bearing. In this video we will see this in detail. So firstly we will start with the working of self-lubricated bearing. So in self-lubricated bearing, the bearing prepared by a powder metallurgy process, it is also called as a sintered self-lubricated bearing, or a self-lubricated bearing prepared by powder metallurgy, which has a pores and lubricating material inside these pores. So in these three diagrams you can observe there is one bearing, cut section of bearing, and one central stationary shaft. In second diagram that stationary shaft is rotating, and again in third diagram it is a stationary. So three diagrams I have shown. In first diagram the shaft is stationary over which the bearing is mounted. Then in second diagram shaft is rotating, and in third diagram again that shaft is stationary. So as the shaft speed increases due to the friction, the temperature of the bearing also increases. So in second diagram you can just observe whenever shaft started rotating, due to friction temperature of the bearing will increase, and then because of the heat the viscosity of oil decreases and the flow rate of oil will increase. So whatever oil filled in the first diagram, you can observe oil filled in those all pores or connectivities between the particles. Whatever pores are there, their oil is there, and that impregnated oil will come in between the shaft and bearing because of its low viscosity, and that low viscosity will get due to increased temperature, and temperature will increase due to the friction while shaft starts rotating. So as the shaft in speed increases due to friction, temperature of the bearing also increases. Then because of the heat, the viscosity of oil decreases and the flow rate of oil will increase. Hence the oil will get pulled out from the pores and start circulating rapidly along with the rotating shaft. So in between that bearing and shaft, in second diagram you can observe oil layer has formed. So that oil layer will act as a lubricant between the shaft and bearing. And when the speed of the shaft decreases, both the pressure as well as temperature will also decrease. So in third diagram you can observe whenever the shaft speed has decreased or shaft becomes stationary, then the pressure temperature has decreased, and due to this, with the help of capillary action, the oil goes back into the pores. So there is no wastage of oil and bearing works smoothly and silently. So due to the decreased pressure and temperature when shaft is stationary, with the help of capillary action the oil goes back into the pores. So in third diagram as in first diagram you can observe similarly the pores automatically get filled with the lubricant oil because its viscosity again has been increased, and due to the capillary action they have again taken the initial position. So like that the self lubricating bearing will act. So this is after this working, the characteristics of self-lubricated bearing. What should be the characteristics of this bearing? If you understand the working, then characteristics will be related to this working also. So the sufficient amount of porosity must be made, that is 30 to 40% porosity must be there to retain the maximum possible amount of oil. To retain oil, those bearing must be having the porosity, and that controlled porosity we can achieve with the help of only powder metallurgy process. That's why this is made an important application of powder metallurgy. Secondly, the interconnected porosity which distributed throughout the metal. So the porosity must be interconnected. So in this diagram also you can observe those pores are there, which you can observe here as a large sized, and these are actually not that much large, but these are interconnected so that oil can flow from each pore to the gap between the shaft and bearing. So these pores are interconnected. Next, to sustain the load, bearing should have the high strength. To sustain load, these bearing must have the high strength, isn't it? The directional accuracy of the bearing, sorry, dimensional accuracy of the bearing is also or must be good, because the gap between the shaft and bearing must be very small so that the lubricating oil layer will form, and this will act as a lubricant. If that gap is too much, there will be out, or that lubricating oil will not perform its function. So that's why dimensional accuracy of the bearing must be good. Again, the porosity is inversely proportional to strength. So such bearings have more oil retain capacity uh, than the less load carrying capacity. So these bearings are having a less load carrying capacity, but they are actually good working at a very high speed, isn't it? Those are the some characteristics of bearing. Then applications of these self lubricated bearing, where we can use this bearing. So these bearings are generally, just now I have told you, these bearings are generally used for the high speeds, because at a high speed these can take the position between the shaft and bearing as the thin lubricating film. But for the low load conditions, high speed and low load conditions, wherever are there you can use this self lubricated bearing. They can also be used where the direct lubrication is not required. Many applications are there, such as Xerox machines, injection molding machines, automobile parts, wherever direct lubrication we cannot do every time. So there these bearings are used. Again, they are used where oil should not come in direct contact with the product, or whatever your manufacturing machine is there, in that some food industries are there, or food equipments or textile industries are there, where in actual product that oil should not make a contact. So in those cases you cannot do the lubrication every time. There it must be self lubricated. So they are used where the oil should not come in contact with the product. So in these applications, generally the self lubricated bearings are used. So in this one of the short video I have shown, so here you can observe the many of the applications are there, where you can observe, consider this is Xerox machine, and in that Xerox machine, wherever the page has been circulated, new page comes, all those things are having rollers, and those rollers are mounted on the bearings. There you are not required, or you are not supposed to use the lubricant. That lubricant is gained by the self lubricated bearing only. So many such application in textile industries also, and in compression machines also, there are the self lubricated bearings used in many applications. Whatever application just I have now told you, same applications are shown here in this video. This is injection molding machine. Here also, see here. So these connected, whatever silver colored are shown, those are the self lubricated bearings. This is again a press machine, wherever the connections are there or clips are there between the upper pressing plate and downward pressing plate. There are also the self rotative bearing in four wheelers. Many places are there where you can use the self lubricated bearing. Those are shown in this animation. So in this truck also you can observe in its rear axle as well as wherever leaf spring is there also it carries a self lubricated bearing. In JCB excavator, at every joint it is having a one kind of bearing which is also a self lubricated bearing. In dams also, while opening and closing the doors, those bearings are also used. Frequently they don't need to apply the lubricant, they are self lubricated and manufactured by either powder metallurgy in many cases. In that pump also, in windmills also self lubricated bearings are used. So in dams also, in many cases, hundreds of years no lubrication is required in such places. So for those cases, self lubricated bearing is very important. So those are the applications of self lubricated bearing. So there you can use this kind of bearings easily. So up till now we have seen the working of self lubricated bearing. Then what are the characteristics must be there for that self lubricated bearing and the applications of self lubricated bearing. Now, those self-lubricating bearings are prepared generally by the powder metallurgy process, or those are also called as a sintered metal self-lubricated bearing or oil impregnated porous bearings. So in exam they may ask like this: explain the oil impregnated porous bearings or explain the self-lubricated porous bearings, uh, or they may ask the sintered metal self-lubricated bearings. So those are one and the same one. The bearings which are manufactured from the powder metallurgy are called as sintered metal self-lubricated bearings or oil impregnated porous bearings. Here no need of supplying the continuous lubricant oil because they are having oils soaked, or it is called as a pre-impregnation. They are impregnated in oil previously or at the start only. They are utilizing the same oil continuously for hundreds of years. So the bush as well as bearings can be made by using the powder metallurgy process, which are the self lubricant. So whenever they are getting heated with the help of friction, they release the oil stored inside the pores, and the oil forms a hydrodynamic layer due to the wedge action, and on cooling the reabsorption takes place due to the capillary action that we have seen in the working of the self lubricated bearing. The material used for this manufacturing of the self lubricated bearing is bronze, brass, iron, or aluminum powder with or without the graphite. So graphite is very important constituent here. Graphite need to be added in many cases, but the actual material for this manufacturing of the self lubricated bearing is a bronze, brass, iron and aluminum. So this is the flow chart of the self lubricated bearing by powder metallurgy. You know the steps in powder metallurgy. First step is preparation of powder, second step is mixing and blending, third step is compaction, fourth step sintering, fifth step secondary machining operations, and last step is testing and inspection. So by these 6 steps you can prepare a component by powder metallurgy process. So here also powder metallurgy steps for the self lubricated bearing are shown. In exam you need to draw this flow chart and then you have to explain each step one by one. So for this video we will stop here. In next video we will see all the steps in detail for the generation of self lubricated bearing by powder metallurgy process. Thanks for watching.